Hello everyone, what is up? My name is Brian Thomas and welcome back to my YouTube channel. So guys, what did we do in the last video? We saw an introduction to regression. Okay, so we saw different topics like regression, what is a fit line, what is a scatter plot, what is a linear regression graph, and various other things as well. So we just saw a overview of regression. We didn't see what exactly regression is, how it works, what is a program written for it. We didn't see all of that. We didn't get technical in the last video. It was just theoretical and very basic. But in this video, it is not going to be the same. We are going to get a little technical. It might get a little boring, but I'll try to keep it as interesting as possible. So guys, have some trust in me and please watch the video till the end. Okay? So guys, without wasting time, let's get started. So guys, as you all can see, what is today's topic? It is just regression. Created by whom? Obviously, Brian Thomas, that's me. Okay, so we'll come to the next slide. What are we going to be doing in today's video? That means the different topics that we're going to be covering. Okay, so the first thing that we are going to be covering is the linear regression formula. Then we come to how to calculate a fit line. Okay, then we come to calculating a fit line with an example. So in the last video, what did we see? We just saw what is a fit line. We didn't see how it is calculated. But in today's video, we will be seeing how it is calculated, what is the formula that's used, what are the different steps that are there in calculating a fit line. And I have also written a program. So we are going to be seeing the calculation of a fit line with an example. Right. Then we come to the table for fit line. Exactly. So after we calculate various values of the fit line, we need to, draw a table just for our understanding, not necessary. So we'll come to that as well. Then we come to linear regression with an example. Like I was telling before, we are going to be performing linear regression on a real problem. Okay, so we are going to be calculating, we are going to be predicting as well values. So it's going to be very interesting, right? Then we come to the different use cases of linear regression. That means where all linear regression is used. So now we come to the first topic, that is the linear regression formula. The linear regression formula is the same as that of the fit line. And what was the fit line formula, if you can remember? Just pause the video, try and recollect what was the fit line that we had seen in the last video. I know y'all know the answer. Come on, think. Absolutely right. So we'll just come to that. We'll come to the formula. Let's read this line now. So the calculated fit line itself is the predictions. Okay, it generalizes the data and uses the generalized data for further unseen predictions, right? So what is generalization? If y'all are new to my channel, y'all have not seen my first video, then y'all might not know what generalization is all about. So I recommend y'all that y'all go to my channel and watch the first video, that is Introduction to Data Science. In that y'all will see what is generalization. Okay, don't get panicky or something, just see the first video. It's pretty simple, y'all will understand it within a second. Now, as you'll recollected, which is absolutely right, the linear regression formula is equal to y is equal to mx plus c, right? Where y is the y coordinate, x is the x coordinate, m is the slope, and c is the y intercept. It's as simple as that. We saw that last time, not a big deal. Y'all all remember it. Now we come to the important part, that how do we calculate this fit line? Okay, so first, what do we have? Let's just check that what do we have, what is the fit line, how do we calculate it? Okay, so to calculate the fit line, we have the formula y is equal to mx plus c, where we have the x and y coordinate. Now if you all recollect the scatter plot that we had seen in the last video, to draw those points over a graph, you need the x and y coordinate. Am I right? Yeah. So we have the x and y coordinate out of 4 variables, y, x, m, c. We have the x and y coordinate. What do we need? We need the slope and y intercept, right? That means we need the m and c, right? So exactly that I've written here. We have the x and y coordinates, hence we have 2 variables. And what do we need? We need to find the remaining 2 variables. That means the slope m and the y intercept c. So the first step that we need to do is find the summation of the x and y coordinates. So we have a list of x and y coordinates, we have a list of x coordinates, we have a list of y coordinates. What do we need to do? We need to actually find the sum. That means sum the x coordinates and sum the y coordinates. That's the first step. The next step, what do we need to do? We need to find two variables called x bar and y bar. Now what is x bar and what is y bar? X bar is nothing but the average of the x coordinates. How do we take out the average? We just sum up all the numbers of the x coordinate and divide it by the number of elements in the array. That means you have the x coordinates, maybe you have 10 coordinates, just add all the 10 coordinates and divide it by the number of coordinates. That's as simple as that. So we need to calculate the average of x and the average of y as x bar and y bar. That's the second step. Then we come to find the values of x minus x bar and y minus y bar. So again we'll have a list of values x minus x bar and y minus y bar. So again we'll have a list of values x minus x bar and y minus y bar. Then we need to find out something called the product. Now what is this? We need to multiply x minus x bar into y minus y bar. So if we have a list of x minus x bar values and a list of y minus y bar values and we multiply both, we'll again get a list of values called product. So we'll have product, we'll have a list of values, and then we need to find the summation of product. That means we need to find the sum of all the elements that are present in product. Okay? And then we need to find something called square. Square of what? Square of x minus x bar. That means we have to calculate x minus x bar into x minus x bar. We get a list of values. Now what do we need to do? We need to sum these list of values and this will be the summation of square. So what do we have now? We have the summation of product and the summation of square. These are the two things that we have right now. Then we need to find out slope. That means the slope of the line. Now how do we find this? We'll come to that later. Just stick with this right now. I'll just show you the program. There I'll show you how do we calculate the fit line. Right. So we need to find out the slope that we'll see right now in a minute. So this is done. Then what we have? We have the slope that we calculated right now. And now we need to calculate the y-intercept. That means we have the slope, x coordinate, y coordinate. What is remaining? Just one thing is remaining, that is the y-intercept. That means c, right? Yeah. So again we get x coordinate, y coordinate, the slope and the y-intercept. We got all four. But what do we need? Do we need all four? No. We need three. Just three we need. What is the thing that we don't need? We don't need is the y coordinate, because the y coordinate what we have is not very the correct. We need to improve the y coordinate. That is why we are drawing a fit line. That is why we are going for linear regression. Is because we are improving the points, the y coordinate. We are improving the y coordinate. So we have to calculate the y coordinate again. What is the formula? Y is equal to mx plus c. So we have the x coordinate, slope and the y-intercept. What is left to calculate? The y coordinate. Not a problem. We have all the three values. We can calculate the y coordinate very easily. Am I right? Yeah. So the next step is, now we have the slope and the y-intercept, right? Then using the slope, y-intercept and the x coordinates, we need to find the value of y. That means the value of y coordinates. So now we have come to the table. So this is just a table. So as you all can see, we have the x coordinate at the leftmost, then we have the y coordinate, then we have x minus sum of x, that means x minus x bar, then we have y minus sum of y, that means y minus y bar, then we have product, then we have square, then we have y final. Now y final is nothing but the improved y coordinates that you can see right there. Okay, and then we have the MSE, that means the mean square error. We saw that last time. I know you remember that. Come on. Yeah. So we saw that last time, don't forget. So we saw mean square error. Now what is that? That is y minus y bar whole square. So if you just look at the table right here, we have the y coordinate and then we have y final. Can you all see any difference between the two? We have the y coordinate as 96.11, the first row if you all see, and then we have the y final, that means the improved y coordinate as 99.22. 2182. What is the difference between the two? 3 points. Am I right? Yeah, it's approx 3 points. I'm not very sure. Now, what is the square of 3? 9, right? So if you'll see the mean square error, we have y minus y final whole square. That means y minus y final of the first row was 3. What is the square of 3? It's 9. That's exactly the answer that you can see right there. So this way you have all the points that you all have seen right there. Okay? Yeah. So now we are going to be going to our Jupyter notebook where we have the program ready for calculating the fit line. As you all can see, this is my Jupyter notebook that I have created only for y'all, so that you all can understand very easily what is regression, what is a fit line, how do you calculate a fit line. Okay, so I am trying to put in a lot of efforts. Please understand the efforts that I'm putting in and try and share my video, like, comment on it, and enjoy and keep learning. That's all I can say. So yeah, as you all can see, we have the Jupyter notebook open where we have fit line. In that, we have again written the steps to calculate the fit line. We saw this in the PPT, right? Yeah, so we have two variables, you have to find two variables, and this is all the, the steps that we are doing, right? Yeah. Now we are doing something called, okay, so now if you'll see on the screen, we have a whole program written there. That means in one shot, I have the whole program ready. I'll show you all how it is done, not a problem. Let's come to the output first, 1 minute. So we'll come here. So as you can see, we have the x and y, the x coordinates and the y coordinates. This is solely given by me. I have just typed random numbers. That means x coordinate and y coordinate. Now, what these numbers are? So as you can see, we have the x coordinate and the y coordinate. Okay, right here we have the x, and right here we have the y coordinate. Now, what these are? These are not random numbers. So I've thought something and put these numbers, right? Yeah. So if you'll just take a problem, for example, that we all are students, we study, right? We have exams, we have got a lot of things to study and all that. Now we just calculate the number of hours that we put in for studies in a week's time. Okay, so we get a total of 168 hours. 24 into 7 is 168. Okay, so out of 168 hours, how many hours we are putting for study is how much percentage we'll get in the exams. So if we put more number of hours of studies, we'll get better percentage in our exams, right? Of course, why not? Unless there are some exceptions like Einstein sitting there. Okay, so if you'll see the x and y arrays, the first value of x is 140. That means a student is putting 140 hours for studies in a week out of 168. What is the percentage he's getting? He's getting 96.11%. These are just random numbers that I've put. If he's studying a lot, he might get a good percent. These are just my numbers that I've put, so don't worry about that. If you'll see the next number is 100 hours. And if the student is putting 100 hours, he may get around 80.63%. So this way, if you'll see, just correlate all the numbers and you all will see that how many hours students are putting, that many numbers the students are going to be getting. So same way, we have plotted a graph using these two variables, the x array and the y array, and we have got this scatter plot that you can see right here. So this we have the study as weekly, and here we have the marks in percentage. Okay, so first thing, like I showed you in the PPT, the first step is we are calculating the sum of x, that means the summation of x. Then we are calculating x bar, that means the average of x, summation of x divided by the total values of x, that is 15. So x bar we got is 92, same goes for y, summation of y, and y bar we got. Then we are performing x minus x bar and y minus y bar. We are getting the following values. So x minus x bar we are getting as 48. If you don't trust me that what these values are you right or something? So if you just check, first value of x is 140, right? Yeah. And 140 minus 92 is how much? Come on, can't be so slow. 140 minus 92 is 48. Absolutely. The same way, all these values are properly calculated. X minus x bar, all these values, and y minus y bar as well. Okay. Then we have product. That means x minus x bar into y minus y bar. Okay. So product, we get the list of product. Square is x minus x bar whole square. Again, we get a list of values in the square. Okay. Then We're doing a product summation and square summation. We're getting the following values, as you can see right there, right? And then what are we doing? So as you can see, we are calculating the slope of the line. Now what is the formula to calculate the slope of the line? We have the product summation divided by the square summation, and hence we get the slope of the line. Pretty simple, right? Not a big deal. Absolutely. So now we have the x coordinate, y coordinate, and the slope of the line. What is most important that we need to find right now? The y-intercept, right? Just substitute these values in the formula, that y is equal to mx plus c. You can see right here that there's the formula, that's y is equal to mx plus c. Therefore, to calculate the y-intercept, what do we need to do? We have y-intercept, that means c is equal to y minus m into x. Therefore, we get the value of y-intercept as well. So we got the two most important values. We got slope and we got the y-intercept, and we have the x coordinate. Therefore, we need to find the y coordinate, the improved y coordinate. Okay, so therefore the equation is y is equal to the slope into x and the y-intercept. Here I have just printed the x and y coordinates, and here I have printed something important, the mean square error, y coordinate, the the input y coordinate, and here is the final y coordinate, the improved y coordinate, right? So as you can see, 99.16 is what we're given, 99.2182 is what it has improved it to, 80 to 74, 35 to 23, 48 to 45. So there are big changes and there are small changes as well. Not a problem. Cool. So we get to see this, all this list, and here we have the mean square error. And here is something important that we are doing. Now we have the x coordinate unchanged. That means what is given is kept as is till the end. But we are changing the y coordinate. We have given the y coordinate something, but we are again calculating improved y coordinate to get better results, right? So in the array of x coordinate, we have a minimum value and a maximum value. Same way in the array of y coordinate, we have a minimum value and we have a maximum value. So to draw a fit line, what do we need? We need the minimum xy coordinate and the maximum xy coordinate. Therefore, we will be able to draw a line between the two. Am I right? Yeah. So that's how we draw the linear regression graph in which the fit line is drawn using this method. So we saw the steps, we saw an example. Program, I'll just show you the program, what we are doing, not a big deal. You can do it as well. If you know the steps, it's very simple, you can do it. So this is what we're doing. We're calculating the fit line this way. So this is the graph. This is a scatter plot without the fit line. We come down here, and this is the scatter plot with the fit line. Therefore, it is called the linear regression graph. So we'll just come here, program in parts. That means here I've just divided the program into various parts. Same program that we have on top. We're first importing matplotlib. That is the library that we are going to use for visualizations. That means this is what is helping us view the graphs, scatter plots, and the linear regression, fit line, everything. Then we have the same xy coordinates that I've given right here, specifying two variables, length of x, length of y, printing the xy coordinates this way, and here we are drawing the scatter plot. That means by plt, because we are doing import matplotlib.pyplot as plt. Therefore, plt.title, x label, y label, and scatter the x and y, these two. So it draws the scatter plot. Then the first step, summation of x and y and x bar, y bar. So just using a for loop, calculating the x, summation of x, printed the summation of x. Then we are doing a small round off because the summation of x is a long number, decimal points and all that. We're just rounding it off to a small number, and then we are printing x bar is equal to this, and we're calculating the x bar. Okay, x round off is round of x addition divided by the number of variables in x. So number of elements in x, sorry. So we're calculating this right here. Same goes for y. We're calculating the summation of y and the average of y, and then we are calculating the y bar. This is what we are doing. Then we are calculating the xi minus x and the yi minus y. Same thing as x minus x bar and y minus y bar. Okay. Same way, looping in it, calculating all this, appending it into a list. Okay, doing it. We got this right here. Then we are calculating the product and the sum. That means x minus x bar into y minus y bar. The product, you get a list of elements, and then we are doing x minus x bar into x minus x bar. That means a square. Again, we get a list of elements in the square. Just look at this program. I'm not explaining anything. It's pretty simple. Just pause the video and watch the program. Okay. So we get the product, we get the square, and then we're also calculating the product summation and the product square. Now we're calculating the slope. Slope is what? The product summation divided by the slope. Oh, sorry, slope is equal to the product summation divided by the square summation. So we get the product as well there. And after we get the slope, what do we need? We need to find the y-intercept, right? Yeah. So therefore we get the y-intercept like this by using the same formula. That means y-intercept is equal to y minus m into x. Okay, yeah. So slope, we get the equation right here. Then the program output overview, we have y, we're just doing different things, printing the MSC and y bar and all. Yeah, here we are plotting the graph. This is the x and y coordinates, MSC, y bar, the final numbers, and the minimum of x coordinate and y coordinate, and the maximum of x coordinate and the maximum y coordinate. This is what this line is all about. So if you don't trust me, if you still have a doubt at what this guy is talking about, we need to confirm once, right? He क्या बड़बड़ करते रहता है. So then we have the x coordinate as 10 and the y coordinate as 17. Okay, if you just look here, the x coordinate might come somewhere here. Sorry, the x coordinate might come somewhere here as 10. See, it's pretty away from 20, right? So it will come somewhere here to 10, and the y coordinate will come 17, pretty close to 20, somewhere here. But this is the improved one, right? That's why this line. The previous y, if you would see the input y, the smallest number, it will be above 20. See here, which is the smallest number that you all can see, 21. See exactly. The input y that we gave was 21.66. It improved it to 17.389 or 17.34. 389 exactly. So here we have the input y coordinate as 17, but the input y coordinate was 21. You can see that right here. The maximum the maximum x coordinate is 155. You can see we have 160, somewhere close to that is 155. Coming right here on top, this red bar. And here we have the y coordinate, maximum y coordinate, a little bit over 100, coming right here to this point. Still, if you don't believe me, this was the y coordinate as the input, and this is the y coordinate improved. Let's check. So find the biggest number. That where is 108? Can you all see? Yeah, see, we have 108 here as the improved y coordinate that we just saw here. 108. What was it before? It was 98.56 before. 10 units less right here. 98, very close to 100, below 100. This is the point. Input y coordinate, we improved it, right? Of course. Then we are cross-checking the y coordinates. We have the input y coordinate, the x coordinate and the y coordinate, x coordinate and the y coordinate. Again, x remains as is, but y changes. You can see right here, right? Yeah. So there you go. We have calculated the fit line. We've seen our fit line is calculated. Very simple, pretty small, not a big deal. So let's get back to the PPT where we will be now seeing linear regression and going to the program where we are calculating the predicting values using linear regression algorithm. So you can see right here on the graph as well. Again, we have the scatter plot and then we have the linear regression graph. Cool. Now we come to linear regression. Consider this example where if a student studies for more hours a week, the better percentage he gets. See, I've already said this, I'm just repeating it. See, I've already said this, I'm just repeating it. Okay, so what do we need to do? We need to create an Excel file. We need to just make two simple columns, study, marks. Just add values for studies out of 168 how many hours and correspondingly give the percentage for marks. कितना ज़्यादा पढ़ता है उतना ज़्यादा marks पढ़ेंगे. Exactly, है कि नहीं? So exactly. So after you make this Excel file, just save the file. That means the Excel is saved. Then after saving the Excel file, save as. Don't save again, just go to save as and save the Excel file as a CSV comma separated value. What is a CSV comma separated value? Remember that. Save it as a comma separated value file. Okay, once that is done, then we'll be coming to the program and I'll show you how to write a program and use these CSV files for calculating and predicting marks. Now if you notice the data, it is clearly seen that the data is completely linear. How much you will study is how much you're going to get. If you're going to study this much, you're going to get corresponding percentage. But if you're going to be studying this much, you're going to be getting corresponding percentages. Therefore, the hours of study that you put in is directly proportional to the amount of percentage you're going to get. Cool. So before we come to the use cases of linear regression, we'll just go to the Jupyter notebook again, where we're going to be seeing the linear regression program. There you go. So here we have the linear regression program that you can see right there on top. We are importing required packages, pandas as PD. Now as PD is called alias, we are using them in programs as alias, so we don't need to type pandas everywhere. We can just type PD. The program will understand that it is the short form or alias for pandas. Then we have from matplotlib import pyplot as PLD, the same thing that we did before. Then we have from sklearn import linear model and %matplotlib.inline. So first thing that we're doing, creating a data frame using the regression CSV. So like I told you before, we write in an Excel file, save that file as a comma separated value, that means a CSV file, and here we are creating a data frame using the CSV file. Okay, so we are saying df is equal to pd pandas dot read CSV, and we give the name of the file, that means regression.csv. But remember one thing, wherever you are creating this Jupyter notebook file, in the same directory, in the same folder, paste this regression file or create this CSV file. Create the CSV file. Then it will work pretty well. Otherwise, you all will have to hide the whole file path and all. It's a big headache, not a problem. Better method is just put it in the same place where you all have the Jupyter notebook. Okay. And first we are reading the CSV file. After reading the CSV file, we are writing df, that means data frame. So it will just print the whole data frame. Now this data frame, it will print the whole data frame that I've written here. That means 15 values it has right here, starting from 0. If you just now imagine if you have a 10,000 values, if you just type df, it will show 10,000 values. You don't want that, right? It's a big headache. Who's going to see 10,000 values? So what you need to do, you just need to see a small amount of values. That means the beginning values. Just do this. Type df dot head. You did this. Oh, I'm sorry, I didn't run it. Just run. Boom. As simple as that. So before it was printing maybe 15 values, but now it is just printing a small amount. That means the heading values, the beginning sum values. So we have the study, we have the marks values in them. Now we are plotting the scatter plot. We saw that before also, same thing. plt.scatter, not a big deal. Then we're importing the train test split for bifurcating the data for training and testing. I'm sorry, spelling error. It is bifurcating. I have written bifurcating. Okay, so here we are importing train test split for bifurcating the data. Oh my god, for bifurcating the data into training and testing. Okay, cool. So we are splitting the data. That means data frame dot study into 1 and data frame dot marks into 1, and then we are saying the training size has to be 0.8. That means 80% of the data has to go for training and the remaining 20% will go for testing. So here we're checking the training data set and the testing data set. So we're just printing the X train. So 80% of the values, that means out of 15, 12 values have gone for training. Y train, again, here we have the hours of study in the X train, and here we have the percentages, corresponding percentages in Y train. Now if you'll notice, these values are all jumbled. It is not 0, 1, 2, 3, 4, it is 0, 2, 3, 6, 1, 8, 14, whatever. But here in the Y train, it's corresponding 0, 2, 3, 6, 1, 8, 14. Okay, so corresponding marks, corresponding percentages, it is trained that way. It is said that okay, this is how I'll remember and I'll learn this way. Then for testing purposes, it has kept 20% of the data. That means 3 again values for testing purposes in the X test and the Y test. That means the hours of study and the corresponding percentages. Cool. Then we are doing is we are importing linear regression and creating a linear regression object. So before I forget, we are going to run the program, right? Let me just run all this. So if you are wondering how I'm running all this so fast, press Control and Enter. That's how it runs so fast. Don't need to keep on right click and run and all that, whatever. Import linear regression and create a linear regression object. So then we are saying reg, short form for regression, is equal to linear model dot linear regression. So we're just creating an object for linear regression model. Run this. Now we are trying to fit the data into the linear regression model. That means regression dot fit the X train and the Y train, because that's what it's going to train on, right? Yeah. So it said okay, fine, I'll train on them. Now it is trained. As simple as that. Very small data, right? Takes less than a second. It's already trained on them. Not a problem. Now we need to predict. This is where it comes pretty interesting and cool. Okay. So here we are predicting. I'll just run this program. What do we have right here? We have predictions is equal to regression.predict 10. Now what is this 10? 10 is the hours of study. I have said that okay, fine, if I tell the program that I have put only 10 hours of studies, predict how much percentage I may get. So here I've just said print predictions, and after that just a percentage sign. So as 10 hours, how much percentage will I get? 19.77. That means 19.8%. I'm going to fail pretty bad. But if I put 100 hours of study out of 168, let's just see how much percentage we'll get. 69. Okay, not extremely good, but yeah. I know what you're thinking. Okay, so if you put 100 hours of study out of 168, we are going to get 69 percentage. Okay, so now if we just change that to 120, how much are we going to get? We're going to get 79 percentage. If we make this 150, come on, extremely studious guy, maybe very studious, wants to get into IIT or something, studying 150 hours a week out of 168, big deal. Bookworm, whatever you call him. Let's see how much he'll get. Wow. So if you put 150 hours of study out of 160, you may tend to get 96.39%. It's pretty great, right? What more do you want? Let's try 160. If you put 160 hours, that means just 8 hours of sleep and eating food and personal work out of 168 in a whole week, you're going to get 101%. Wow. Let's just try the extreme case. If you put 168 out of 168, how much are you going to get? Okay, so if you put 168 hours out of 168, you will get 106%. Not bad. Okay, so here we have the coefficient. We are printing the coefficient using regression.coefficient, and then we have the y-intercept. Printing the same using regression.intercept. We are going to get the y-intercept as well. Then we have the formula, that means y is equal to mx plus b. Make it mx plus c, anything is just a constant, not a problem. So here we are printing y is equal to 157 into coefficient plus intercept, print y. So again, if you put 157 hours, you're going to get 100%. Same thing if I put 15 hours. Lol, who does that? You're going to get 22%. What more do you expect? Yeah. So basically this was all for linear regression. We made a model very easily. We predicted values using this model. So first of all, I would like to congratulate all of you all, because this could be your first ever program or the first ever model that you all have made using machine learning algorithms, and a very basic one for that. That means linear regression. So congratulations, you all have made your first predicting model using machine learning algorithms. So you can see right here, even Leonardo DiCaprio is here to congratulate you all. I know it's pretty cringe, it's not at all funny, but please don't judge me. I'm trying. So thank you for this staying till here. Now just stay a little bit longer. We have a last small part to cover, and we'll just come to that. So basically that is the use cases of linear regression. Okay. So what are the different things linear regression is used in? So first thing, if you're traveling somewhere very far and you want to calculate the efficiency of your vehicle, and you have the data collected for some reason, maybe you're constantly tracking of how much fuel the vehicle is consuming wherever you're traveling. and you have the data with you, just like we had the data right now. You can use linear regression to calculate that if you're traveling over a distance of these many kilometers or these many miles, you're going to consume this much amount of fuel or gas. That's the first thing. Then businesses often use linear regression to understand the relationship between revenue and ad spending. But of course, the relationship is pretty linear. The more money you're going to spend on marketing, the more revenue that you're going to generate through ads. So this is also another method that businesses use. Then again, linear regression is used even in the medical field, with doctors. Okay, even doctors use this. Doctors use linear regression to understand the relationship between the drug dosage and the blood pressure of a person. So how much drug dosage you're going to give, maybe that could increase the amount of blood pressure. So you can use linear regression here as well to understand this same. Okay, now again, data scientists also use linear regression. That is their job. They are supposed to be using that. So data scientists also use this to understand the relationship between different training regimes and the performance of an athlete. So which training is affecting the athlete the most, which is providing the most value to the specific athlete, and which is getting the athlete the more outcome, which training exercise. So data scientists also use this linear regression to understand the relationship between the same and derive to a conclusion that okay, this exercise is very good for this athlete, stick with it and keep going on with it. Yeah, you're going to improve. So you can do that as well. So these are all the use cases of linear regression. Now it's over, guys. This whole video is over. The content is completely over. So we have completely covered linear regression, the basic part overview as well as the technical part, and we are completely thorough with it. So thank you all for watching, guys. It's been pretty great that you'll have been till here in the end. Okay, now you all have just one job to do. Okay, what is that? You all have to do this thing. Yeah, this is what you need to do. You need to also share, like and comment below. I'm trying to make the video more humorous, trying to make more PPTs and make the Jupyter notebooks more visually pleasable as well. Please understand the effort I'm putting and keep supporting, like, share and subscribe to my videos and nothing else. And once again, thank you all for watching. See you all in the next video very soon. Until then, bye.